Okay, now, graph trapezoids are usually, when we use them in applications, they're going to have a meaning, or frequently they'll have a meaning. And this is one of the really important aspects of graph trapezoids in a context of the application of mathematics. Okay, so if we have a graph trapezoid whose left altitude is 10 meters per second, right altitude 20 meters per second, and width 5 seconds. What's the slope? What's the area of this trapezoid? You should calculate these. And in your calculation, you should include the units at every step and do the algebra of the units carefully and accurately. It's just the algebra of multiplication and division of fractions. That is something that unfortunately is not well taught in our public schools and gives people all kinds of problems that usually, in many cases, don't get reconciled for the full duration of a course for a whole year. Something needs to be reconciled and understood immediately. Okay, calculation of the slope is quite straightforward. We geometrically construct a run and a rise segment. The run is 5 seconds, the rise from here to here, and maybe I ought to do this because people always tend to use the whole 20 meters per second here as the rise. And I'll note, yes, this isn't drawn to scale, this is just a representative trapezoid. 10 meters per second here should be as big as 10 meters per second here if we want to have it done to scale. In any case, we divide then the 10 meter per second rise by the 5 second run. 10 divided by 5 is 2. A meter over a second divided by a second is a meter over a second squared. Now, people will just eliminate the second. There's a second up here and a second down there, so let's cross them out and cancel them. That's totally invalid. I don't even want to see cancellation anywhere in this course. I probably will, so yeah, I'll probably mention it to you, but I really don't want to see it. I want to see valid mathematics, and cancellation is unfortunately not used in a valid manner consistently by students who come out of our curriculum. A few, yes, and you might well be among the few. Still, I would avoid it. Okay, in any case, now we want to calculate, and if you don't understand why that's meters per second squared, I'll explain it in a minute, but I'll leave that to the end so you can ignore it if you understand where that came from. Okay, so average altitude here, well, I'm going to take my midpoint, and I'll just kind of draw a little line over here, and a very bad vertical arrow here, to indicate that the average altitude is clearly 15 meters per second. And if you can't look at 10 and 20 and see that the average is 15, you need to put away your calculator for about 5 years. Okay, there's your average altitude, 15 meters per second. So that the area equals the average graph altitude times width. If you want to think length times width, okay. But this is a special length, and I'm going to call it the average altitude, and it would be good if you would think in those terms as well. Just help you keep things straight and keep straight the meanings of the various quantities. So now we have 15 meters per second multiplied by 5 seconds. That comes out 75 meters. And ultimately, this is because second divided by second is a unit, and when you multiply a unit by 75 meters, nothing happens. You still get 75 meters. Okay, so the graph altitude is 75, the area is 75 meters, and there's our calculation. Now, an important piece of terminology, excuse me, that I won't always follow, but and I just said it, the slope is 2 meters per second squared, the area is 75 meters. The word is not actually appropriate here. So I'm going to kind of cross it out and say the slope represents 2 meters per second squared. The area represents 75 meters. Now, the 2 meters per second squared, the 75 meters, in turn, represent certain quantities if you give these the information in the original graph a certain interpretation, and we're going to talk about that interpretation. But I'll talk about that in the next video. Just quickly now, I'm going to indicate the calculation of the units. You can stop here if you understand how we got the meters per second squared and the meters here. Okay, the details of the unit calculations. In first place, 10 meters per second divided by 5 seconds. The 10 is divided by the 5. Meters per second is divided by seconds. So, write meters per second divided by seconds this way. It's clear you have a meter per second in the numerator and a second in the denominator of a complex fraction. In a complex fraction, how do you interpret it? Well, the safest way to interpret it is by a division. Meters per second divided by seconds is meters per second divided by seconds. When you divide by a quantity, you multiply by its reciprocal. 2 meters per second multiplied by reciprocal seconds. Well, then meters times 1, well, that's meters. Seconds times seconds is seconds squared. So we get 2 meters over seconds squared. 1.5 meters per second, that's not written real well. It's a little hard to see the, it's not 1.5. It looked like that to me. It looked like a decimal point there. Anyhow, 15 meters per second multiplied by 5 seconds is 15 times 5 is 75. We have the meters over seconds here. We have the times seconds here. Meters over second times seconds is the same as meters over second times seconds over 1. So that comes out 75, of course. Meters times seconds is meters times seconds. Divided by seconds, seconds times 1 gives us seconds. And that then can be written as meters multiplied by seconds over seconds. Seconds over seconds is just a unit which multiplied by anything does nothing to that anything. So the 75 meters times the unit is just 75 meters. Times unity, the unit, you know, that was bad terminology. But seconds over seconds is unity. Multiplying by unity doesn't change anything. It's 75 meters. Okay. That's the details of the unit calculations, and you should understand that thoroughly. The units get more complicated throughout the course. Make sure you understand them. Very important to understand fractional calculations, which again seems to be horribly undertaught and very poorly understood in age of using calculators as an excuse for not understanding mathematics.